Now, the first thing to understand when working with a website is this MetaMask bit. If I right click and I hit inspect, I get this little window over here. And if I hit this double arrow, I can go over to the console. Now, this is a live JavaScript shell, which has a lot of information about the browser that we're working in here. If you don't know JavaScript, don't worry about it. But the most important bit here is that if you have MetaMask or some wallet, what it does is it injects it into your browser object. This browser object in this JavaScript shell is known as the window object. And if I type window in here, I get all this stuff, all these functions that I can call on this window object. And one of the objects that comes with the window is this window.ethereum. MetaMask injects this window.ethereum object into our browser. And it's this window.ethereum JavaScript object that these front ends, these websites interact with to send transactions to our MetaMask or to any wallet that we're working with. If, for example, we were to switch to a browser that does not have MetaMask installed, go to that same site, we right click, inspect, we go over to console, and I type in window.ethereum here, we get undefined because this has no MetaMask. It has no API for us to connect with. The MetaMask documentation has all of the information here that you need to know to actually send and work with this window.ethereum object if you want to learn more. So cool. So this is our website, and we know we have this window.ethereum object. Now, in our HTML fundme F23, if we scroll over to this index.js, we can actually see the code that a website will use to actually interact with our wallet. And usually one of the first things that you'll see is most websites will have some connect button. It's a button for them to know, hey, there is a MetaMask here, and there are accounts in here that we can actually connect to and send transactions to. So here's an example, if you go to this index.js file, of some JavaScript that allows people to connect and work with the MetaMask. This is what one of those async functions will look like. So one of the first steps they do is they check to see that this window.ethereum object even exists. And if it does exist, they'll do something, and they'll call something like this function, await ethereum.request ETH request accounts. This is a function that the MetaMask object has that allows the website to see that there are indeed accounts that it can send transactions to. It's not taking your private key or exposing your private key. It's just allowing the website to send transactions for you to actually sign. So in my HTML here, I've got this button. And again, you don't really need to know HTML or JavaScript here, but I've got this button called connect button. And in my JavaScript, I've got this line connect button equals document.getElementById connect button, and connect button.onClick is going to call our connect function. And this connect function is going to first check to see if MetaMask exists with this line, and then try to connect one of those accounts. Right now, if we go to our MetaMask, we can see here that we're not connected to the site. But if we go ahead and we click the connect button, you'll see MetaMask pop up and ask to connect to one of our accounts, to which we can select an account to connect. And this is how our website actually gets connected. And now we can see, let me switch to account one. Now we can see our account one is indeed connected. Now that we're connected and we have some accounts, we can then lower on call one of these functions. And great. So this website has some functions that look pretty familiar, or should look pretty familiar. We have a get balance, a withdraw, and a fund. This website is actually designed to work with our Foundry fundme that we just created. So if we go back to Foundry fundme, it's designed to work with this contract. If we go to src, fundme.sol, function fund, it's designed to work with fund, and then also withdraw, and then finally see the balance. If I right click and I hit inspect, I hit the drop down, I go to console, I hit get balance, depending on the network that I'm on, I'd get the balance of some address. And if we look in the code, there's this constants folder, which has this contract address that's hard coded in, and we'll get the address of whatever contract is here. On ETH mainnet, apparently there's a contract there. How is it actually making this call? How is it reading off the blockchain? We go back to this index.js and we look for that get balance function. We can see it's doing some interesting stuff here. So first it's checking to see that MetaMask exists. And then it's doing this line, const provider equals new ethers.provider.web3 provider. This ethers package is a JavaScript package that makes it easy to interact and work with MetaMask. Remember how in MetaMask, if we go to our MetaMask, we select the little button, we go to settings, networks, add network. We can actually see in our MetaMask popping up. We can see all these different networks. We can go to add a network manually. Actually, let's just go back to networks. We see that each one of these networks comes with this RPC URL. So what's happening when we call this get balance function, and it looks like for some reason this address has some balance in it, it's making an API call via this RPC URL in our MetaMask. So if we try to call fund or withdraw, it would try to call fund or withdraw onto this address. Now, in our MetaMask right now, we're connected to ETH mainnet. And what we're going to want to do is we're going to want to practice interacting with a real contract using the Foundry FundMe that we just created. So if we pull up our terminal, we'll go down in directory, we'll go to CD Foundry FundMe F23. What we can do is we can say make Anvil, and we'll start a local Anvil chain, create a new terminal here. Now we'll go down a directory, we'll go down back to Foundry FundMe F23. Now we'll run make deploy. This will deploy a FundMe contract onto our Anvil chain. Remember, Foundry FundMe, we go to our Foundry FundMe repo, we go down to our make file, we go to the deploy target in the make file. We see we're running forge script deploy FundMe with network args, which if you don't say anything, it'll default to the Anvil network. So now we ran make deploy, we deployed a contract FundMe to this address. And if you look in constants.js, it looks like that's already the address that's right here. Perfect. So what we can do on the front end then is we go up to our MetaMask, we'll go to settings, networks, add network, and we'll go ahead and we'll add a network manually for Anvil. We'll type Anvil, the RPC URL we can find right here from our terminal. We'll copy that. We'll do http:// paste that in. I already have this network, so it's going to tell me, hey, this URL is already currently in use. The chain ID is 31337. Currency symbol is ETH or Go or whatever you want to make it. And there's no block explorer. And then you'd normally hit save. But like I said, I already have it in here. So we can just select Anvil and boom, all the details are right here. Now in our MetaMask, what we can do is we can flip over to this Anvil chain and begin to interact with this website connected to our blockchain with this FundMe contract that was just deployed. So now we can go ahead and connect. We can hit get balance, which is going to be 0 because we just deployed this contract. And we have our withdraw and fund functions here. Now, obviously, if I try to fund with 0.1, hit fund, we're going to get an error here because this account doesn't have any money. But what we can do is we can grab one of the private keys from Anvil, we'll copy this, we'll go back, go to accounts, import account, private key, paste it in, hit import, and I've already imported it, so it's saying the account I'm trying to import is a duplicate. Then we can scroll down to that account that we just imported and connect to that account instead. And now we have an account with some actual money in it. Okay, great. So now we have an account that's actually connected via the Anvil chain. Now, an important note, if this Anvil chain goes down, or for example, you are following along and you turn it off and you come back to MetaMask, and maybe you'll switch networks, switch back to Anvil, you're going to get this whirling circle of death and you can X out or do something like that. Or you can kill the network and re-import it. Or you can just turn your chain back on, come back, switch over to Anvil, and we're connected again. Now, since you just killed this network and restarted it though, if you did deploy with make deploy, you'd have to run make deploy again. And great. Then we can go back to our front end and we can see it was this account 4 that was the one that actually deployed that contract. So let's do a little refresh to get rid of that warning. We'll go ahead and reconnect. Looks like we're good. If we go to MetaMask here, we're connected. Awesome. So now we can hit this get balance function, like I said, and it's returning the balance of that contract address that we just deployed. So what we can do now is we can call this fund function by putting an amount in the amount section. If I call fund, MetaMask actually pops up saying, hey, do you want to call this fund function? And we're going to go, oh, how does it know actually how to do that? If we go back to our Git repo and we'll go ahead and hide the terminal, not delete it. We can go to our index.js. We'll look for the fund function because we have the fund button, and we're saying fund button on click, call the fund function. We'll scroll down here. What it does when we call this fund function is it gets this ETH amount by calling document.getElementById ETH amount.value. So it's grabbing this 0.1 out of here on the front end. We're checking to see if MetaMask exists on the front end. We're doing this provider line, which gets the RPC URL from inside of our MetaMask. Again, we use ethers to get the RPC URL out of it. We get this signer, which allows us to grab this contract, this account 4 that is connected. This signer equals provider.getSigner. It gets that account 4. And then we're doing this line contract equals new ethers contract. And to interact with anything, remember, we need a contract address, we need an ABI, and to send the transaction, we need a signer. So the contract address we're getting from our constants file, which is right here. And if we pull up our terminal, it's the same as what we deployed here. And if it's not the same, we would just copy paste it in there. The ABI we also get from our constants file. And this ABI has all the functions that we can call on that contract. One of them obviously is the fund function down here. I'll go ahead and hide this again. And then we have this transaction here where we do await contract.fund the transaction, and we send some value by doing this ethers.utils.parse ether, which turns that 0.1 into way. Like 0.1 gets sent to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, right? And that's how this MetaMask actually pops up here, because we're sending this transaction in JavaScript. Now, what this does is it sends the transaction to our MetaMask. So the website never accesses and never actually sees the private key. The private key always stays inside of this MetaMask. So the website sends a transaction to the MetaMask. The MetaMask pops up and says, do you want to sign this with the private key?